So to make a robot, first we have to add the robot part in our Weebots, and inside the robot we will make a shape of the body part of the robot firstly. So as we can see that we are adjusting the size of the body part of the robot, and after making the body we will give it some proper collision and physics, and after giving it we will be focusing on making the wheels of the robot. We will be making the wheels of the robot by using the heel joint parameters and rotational motors, and inside the rotational motors we will be giving it also some shape and a cylindrical size, so that the wheels get is attached with the wheels get attached with the body part and it moves fluently. So as we can see now we are giving a proper transition and the rotation into the heel joint wheel. As we're done making our first wheel, we are giving it physics and also the collision here, and we are also giving it a good color so that it looks nice. And now we are making our second wheel and doing the same thing, and also giving it a giving it the name is really important here, so that the code we will be running also match with these wheels and they can run fluently. So as we can see we are almost done with making our second wheels, and we will be doing this to make the four wheels here. And after making the wheel, now what we will be doing is to we will be doing the anchoring part here. So what anchoring basically means is that we have to do the match the transition values with the anchor, so that the uh, wheels we have created gets attached with the body, and it's make the whole robot move with the whole four wheels and the body here. So we will have to do this with the four wheels. The thing is that we will have to just match the transition value with the anchoring part, so that it moves quickly and fluently. So this is my part, and the next part about giving the sensors and cameras and GPS will be told by my friend Farhan Hussein here. Thank you.
Hello, thank you, Mohibul Hasan, and my name is Farhan Hossein. Let's just start it. In the children part, I have added the distance sensor, and I have modified the settings and the modification I want to add, like shape and some geometry box size and the translation, rotation, etc. I have changed according to my expectation, and as I have seen in the bugs video. After that, I have named this distance sensor as DS left, so that it will work for the left side. And after that I have copied the DS left distance sensor and pasted into the physics as DS right, so it will work as the for the right portion of my distance sensor. Then I have added the camera in another children, and after that I changed the shapes and the rotation, translation, everything according to the sensors, in between the sensors. And after that I have added a GPS in the physics part, so that it will it can remember the map. And I change the height, weight, and basic color, transparency, everything according that you can see in my video. Thank you. And after that, my friend Farhan Farabi will continue.
Assalamualaikum. My name is Farhan Farabi. So this is our robot. Before we start the simulation, we have to implement a code and a controller so that our robot can move. So this is our code. We have implemented a C++ code because the robots have an integrated compile C++ compiler. And after saving the code, we select the controller from here. So now we can play. So we can see that our robot is moving and the object is detected in the camera. So if we press fast fast forward the robot simulation, you can see that whenever it detects an object, it avoids that object. So let's see here, when it detects this wall, it avoids this wall and goes. And you can so now we can see if we can see the library we have implemented: the distance sensor library, the motor library, the robot library, and the camera library. And the 64 time step is 64 millisecond. After that is, if after every 64 millisecond the distance sensor and the camera part will display the image. We create a pointer for robot, and we create a distance sensor. There are two distance sensors, the DS right and DS left, the names which are given here. And we enable the time step. After that, we also for the camera, we get the pointer and get camera value and enable it. We set the velocity, the position of the wheels, and initially the avoid obstacle count is set to 0. And so when the time step is not equal to -1, that is the robot will move normally. That is 1 1. Left speed 1 and right speed 1 means if we change this value, the velocity will increase, the acceleration will increase. And when the avoid obstacle becomes greater than 0, then the right speed becomes -1. That is the robot will, when it detects the object, it moves to the right. And the wheels are set velocity, left speed, right speed, left speed, right speed. If we give them zero negative value, the robot will move backwards. So yeah, if you run it, let's see. We can see the robot is avoiding the object. Thank you.